Hello everyone, welcome back. So in today's lecture, we are going to start a new thing which is deletion. Now we can delete at beginning, same as the insertion. We can delete at the beginning, at end, by value, and by index. So let's just start today by deleting in beginning. Okay, we will take this as an example. This is our linked list. Okay. These are three nodes, A node, B node, and C node. So now A is pointing to B, which is 101 for say. B is pointing to C for say reference of C is 103. Now C is pointing to none since there are no other nodes. Now A is, let's say the A's reference is 100. Since A is the entry point in our linked list, that means that self dot head will be storing the reference of A, which is 100, since A is the entry point in our linked list. So self dot head will be storing the reference of A. Now what I want is I want to delete the first node. Okay, delete at the beginning. I want to delete this first node. So let's just create another function. Since we want to delete at first, so there will be no such parameters. Like we had one parameter in insert because the user was passing the data, which node we want to insert, right? But here it is very clear that we want to delete the first node. So there is no parameters or arguments required. We simply want to delete the first node. That means our linked list, the entry point is A. What if I make my entry point as 101? That means whenever I call this self.head, my pointer will start from this node and not this node, right? So that means I have deleted it. Yes, a node is still there somewhere in the computer's memory, but it's not there anymore in my linked list. Why? Because my linked list is starting from second node now. My linked list is starting from this node and not this node. So there is no reference of a node anywhere in the linked list anymore, right? So that means I have deleted it from my linked list. So what I can do is I want self.head to point to 101 instead of 100. What if I like it like this? Self.head is equals to self.head dot next. Now what am I doing here? I want, let's just remove it. Hmm. I want I want this means self.head. Self.head means this 100 I am saying is equals to self.head dot next. Means self.head, this is self.head, right? Self.head 100 is equals to next means this one. So dot next. What is stored in this next 101? So now my self.head becomes 101. Now also, but before it, we want to handle some test cases. Now, what will be those test cases? Firstly, I want to see whether my linked list is empty or not. What if my linked list is empty, right? What if my linked list is empty? Okay. What if my linked list is empty? What I will do? I'll have to check if self.head is equals to none. right? That means if there is no nodes, if there is no nodes, that means my linked list is empty, right? If there is no node in the entry point, that means it is empty. So I'll simply display linked list is empty, right? Now, what if only one node is there? Another test case. What if there is only one node? That means my linked list look like this. Only one node is there. My A's reference is 100. Self dot head is storing 100. Now when I will do self dot head 100 is equals to self dot head dot next. That means I am pointing this to none itself. So you see, this test case is handling it. Right now, my self dot head is uh, pointing to none. That means I am deleting the only one node available in the linked list. Right. So before it, I'll put it here in the else part. So now it is done. Right. So now let us just delete the A node. What's it? ll dot delete and begin. So now let's before it let's just check how our linked list looks like. Okay, and print something also so that we know. Hmm. Now see, our linked list look like X A C B Y. Now my linked list looks like A C B Y. X node has been deleted. So that's it for this video, guys. If you like it, please like, share, and subscribe. Thank you.